All right, my first vocabulary term today, angle of elevation. Elevation. So that is when somebody is on ground level. All right, so you're on ground level. Here comes the artistic ability here. You're on ground level and you are looking up at something. All right, so let's just say you're looking up at the top of a tree. Or something that's on fire. I don't know. Okay. You're looking at something up to the top of the tree. So angle of elevation is the angle you make by looking up at something. So you are looking up at the top of the tree. But there's not really an angle that I made there. Just by looking up at the top of the tree, I don't really see an angle that I made. It's the angle you looking up to the top and the horizontal line that's drawn in here. Everyone see that right triangle that's formed right now? And everyone see the angle that I made. The angle of elevation is you looking up to the top of something and that horizontal line straight from your eye level. Okay, that's angle of elevation, looking up at something along with the horizontal line from your line of sight. All right, there's angle of elevation. It's always on the bottom of the triangle. All good? Elevation, looking up. All right, well, what if I'm now looking down at something? That's angle of depression. So let's say there's a building here. You're on top of the building, looking down. I don't know why you'd be on top of a building, but just go with it. Looking down to ground level on it, what would we be looking at? Person? I got that one coming up.
Squirrel?
A squirrel on the ground? Okay.
It's just a rock or something.
You wouldn't be looking at a rock on the ground. That's ridiculous.
It's like a really cool rock.
Yeah, it's like a special rock.
Or like a giant geode or something?
Yeah, it's a hard bench.
I don't know why I'm going with this. Special rock. Yeah, you'd be looking down at that, right? Yep. Okay. So where is my angle of depression then? I'm up on top of the building, looking down. All right. So I'm looking down on it, right? Looking down. But where's that angle? And everyone always assumes when I introduce this, that's my angle right there. No. It's the angle formed with you looking down and just like angle of elevation, the horizontal line of sight. So this ends up being your angle of depression right here. All right, so we're going to have to talk when we get to that. How do I use that? Because here's my triangle. But notice your angle of depression's where? Outside it. So how the heck do I use it when I need it inside? All right, so we'll talk about that when we get to it. All right, so depression, looking down, but also it's formed with your angle, your horizontal line of sight. All right, it's not inside the triangle. Everybody good? Depression, not inside the triangle when you're looking down. Maybe I can do this, probably not, but I'll try. Now that's a rock. There we go. All right, now we're good. All right, now we're good. All right. The littlest things I get fired up about. Questions? That is pretty good. I'll just leave it up there for another 5-6 seconds so we can admire. Okay, let's move on. You can always go watch the video, watch the recording again if you want to see that rock. All right. Be your screensaver.
Cool rock.
What's your deal?
It's a cool rock.
Darn right it is, Spence. All right, ready. Let's start using these terms now. So we got Scott here. Eye level, 1.5 meters above the ground, and he's standing 30 meters from the tree. So where can we let's start labeling some stuff now. All right, his eye level, 1.5 meters above the ground. So eye level right about here, above the ground, 1.5 meters. That's about 1.5. Not his height, but his eye level. He's standing 30 meters from the tree. Can you put 30 meters somewhere for me? 30 meters from the tree, Scotty Boy is. So right here, 30 meters. His angle of elevation to the bird is 36 degrees. All right, let's draw that in now. Remember, he's looking up. So eye level, looking up. Along with, where's the other side of the angle? The Good. Horizontal line of sight right there. So that right there, guys, is 36 degrees, your angle of elevation. How far above the ground is the bird? All right, so ground to the bird is what I need to find right there. How long is that distance? All right, so let's start here. Can you see a right triangle I can make? Can we all see a right triangle? Right here, I can make a right triangle by just drawing that vertical leg down. All right, I got 36 degrees. Can anybody find another side length up there? Because if I'm going to do sine, cosine, or tangent, I need at least one side. Anna, you see another side length?
The 30 meters away from the tree.
Remember the 30 he was away from the tree? This is also 30. He's 30 meters away from the tree. Now I'm going to call on a number here, and I need somebody's help here explaining this. Am I going to be able to find the distance from the bird to the ground right now? No. But help me get there right now. What can I find that's going to help me find the bird to the ground? Because you can't just set up one equation, solve it, and I'm going to get my answer. I'm going to have to solve for something else that's going to help me get to that distance. Can I get a little help in your own words just explaining it? Oh, not me, not me. 8. Sophia, you want a little explanation? Go ahead.
You need to find the adjacent side and then add 1.5 to it.
Okay, so what I'm going to find is this side of my right triangle, and then add his height, eye level height, 1.5 to get to the full distance. Everyone all right with that plan? That's where we're going towards now. Find x, and then add 1.5 to it to find my final result. All right, now how do I find x? Sine, cosine, tangent. Let's help me out here. 10. I'm going to go from 36. So what's the x? Opposite, adjacent, hypotenuse. Opposite, and how about the other 30 I knew? Adjacent. So with those two values, which ratio can I use? 10 again. All right, let's go, everyone. Tangent of 36 equals, what's the ratio now? How do you use the 30 and the x? Where do they go? Tangent. 12.
It would be x over 30.
Opposite over adjacent. Good. Make a proportion out of it like we've been doing the last, how many days now? And cross multiply. Hey, everyone, is this my final answer I'm going to get here? Why do I ask you that? What are you not doing? Rounded. Correct. You're going to write that full calculator display out. I know. Stretch out your wrists. That's not my final answer. I'm getting 21.79627584. And then, like we talked about, Sophia told us, hey, after you do that, make sure you add in the 1.5 to find the distance from the ground to the bird. And round to the nearest, make sure, check your rounding directions. 2. Nate, what do you got when you round it correctly?
23.3.
Good. And again, I'm not going to be a stickler for units, but if you want to put on meters, fine. And that's just my final answer. Good job, everyone. Horizontal, looking up. That's the angle it makes. Horizontal with the looking up. Anything from you guys before we go depression now? All right, who we got here now? Big, oh, of course we do. Of course we do. Yep, Big Al. So his friend approaches the building. Ah, the rooftop. Ready? Rooftop, 16 meters. I know I skipped over the 40. I'll get to that last. Big Al's eye level is 1.8 meters from the rooftop. Right? 1.8. So from his eye level, that's 1.8 meters. All right, you ready for the angle of depression now? Because we're going to have to talk. Angle of depression. So he's looking down at his friend. But again, So, hey, that's not 40, right? That's not 40. The 40's formed with that looking down and his horizontal line of sight if he was looking for just straight ahead. That's the 40, everyone, my angle of depression. So we see the right triangle that's formed. I'll highlight it here for you. Here's my right triangle. But like we talked about when I just introduced this, I can't use that 40 because it's outside. Can I get somebody's help to get an angle inside now? How do I can't, like this 40 is useless to me because it's got to be inside for me to use sine, cosine, tangent. Spence, talk to us.
Is it a right angle so you can set it to 50?
Good. This 40 and the angle adjacent to it forms a right angle. So you could say this is 50, or let's go way back to unit 3. Anybody remember what type of angles these were? Alternate interior, and they are congruent. So you got two ways. I don't care which option you do. You say the one adjacent to it is complementary to it, adds to 90, or you put the 40 down here and say it's alternate interior angles are equal. I'll go with Spence's because he was the first one to tell me here. I'll put 50 degrees there. And what are we looking for, by the way? What is the distance between Big Al's friend and the building? Where are you guys putting your X? There's Big Al's friend. There's the building. The distance from it? Yep, there we go. All right, so what sides do I know here? So I can figure out what to use. 3. Spence, what's the X I got to find? Opposite, adjacent, hypotenuse to your 50.
Yes, it's opposite.
That's opposite. Good. And how about this building / eye level over here?
They're adjacent.
That's adjacent. So which ratio should I use in this problem? 9. I have opposite and I have adjacent for SOHCAHTOA. What's that?
Tangent.
Tangent. All right, let's set it up. Tan of 50. Opposite we labeled X. Now, what are you guys going to put in for adjacent? Not 16. 16 and the 1.8 put together. 17.8. Good, kids. Good. Got to put the 17.8 in. A lot of little things here you got to remember. And rounding to the nearest tenth. When you have it, nearest tenth for me, just so I know our rounding's good. 12, nearest tenth. It's got 12.
Oh.
Stop yapping with your girl over here. We would have knew that.
21.2.
There you go. Way to save yourself. Questions, comments? All right. Standing on the gallery. Who knew that was called the gallery, huh? The deck at the top of a light. Anybody ever been on a lighthouse before? Okay.
But excellent that in on
Has anybody ever been in a lighthouse before?
in the lighthouse.
Okay. Nice. Nice. At night? During the day? Day? What?
Afternoon.
Day. Thank you. Okay. Nice. Angle of depression of 20. Sees a boat, angle of or ship, angle of depression of 20. So ready? So we're looking here down, but remember, that's not 20 degrees, that angle I just formed. The angle of depression outside. So draw your horizontal line and put 20 degrees in there. All right, what else do I know? The lighthouse is 28 meters tall. The lighthouse, just 28 meters. And it sits on a cliff that's 45 meters tall. There we go. What is the horizontal distance between the lighthouse and the ship? Now, hey, notice I added in this word here, horizontal distance, right? So I'm not looking for this right here. I'm looking for the horizontal distance. Okay, if I wanted diagonal, I'd write diagonal. but the horizontal distance between the lighthouse and the ship, not the diagonal. All right, what do you want to do with the 20? Because I can't use it. 9, what do you want to do with the 20 to get it inside? Your call.
Make it like 90 degrees.
Okay, so what angle you want me to put right next to it? 70, good. So that's going to be, we'll use 70 now. I always like to highlight my right triangle just to see what I got here, right there. There's my right triangle I'm dealing with. All right, what sides do I have? 10, what's the X? Opposite. And how about this 2845 side? Adjacent. And which ratio can I use now? 3. Spence, which ratio? Yeah, I know. We got to get off this tan bandwagon, huh? Make sure it's tangent of 70, not 20. Opposite. And then what are we putting in for adjacent? That's what I thought. 73. Because I have to add the 28 and the 45. When you have that rounded correctly, let me know. Whoa, 6.
200.6 meters.
There you go, Nate. 200.6 meters. Guys are on fire. Oh, how about this next one? Completely blank. The next one, completely blank. Oh, I am going to be coming around judging everyone's skills right now. Here we go. Angle of elevation to an airplane viewed from a control tower is 7 degrees. Control tower? Anybody drive by the airport know what we're talking about there? Control tower. I'm just making it worse. What, Charlie? I just saw that. Yeah, what? Go ahead. I'll be around in a minute. Don't worry. I'll be over there in a second. Take a look at your pick. All right, yep. Criticize mine all you want. I saw that look. How do I make an angle of elevation? Remember, elevation, we're looking where? Up or down? Up, right? So control tower sees the airplane looking up. Here we go with the horizontal, 7 degrees. I'm looking up, angle of elevation. They tell me the tower is 200 feet high. And now here's what I have to discuss here. What's it mean when it says the pilot reports an altitude of 5,200 feet? That means the plane, from the plane right down to the ground, is 5,200 feet. So ground, where the control tower is at, to the plane right here, that's 5,200 feet. So when they talk altitude, because this won't be the last time you see the word altitude, it's plane directly down to the ground. It's 5,200 feet. Now look, unlike the last problem, what is the diagonal, not the horizontal this time? What is the diagonal distance from the control tower to the plane? So see what you got here. See if you can set something up with there's your right triangle.
Yeah, plane.
The plane.
Control tower. Let's have a light too.
Oh,
And satellite.
Yeah, okay. The plane's decent. Good. Cop out. Total cop out, just putting the rectangle. total cop out. Yep, total cop out. I like it. Nice, good little detail. Are we, is a hammer looking at the airplane there, ladies, or, I could just asking, okay, just checking. Cop out with the rectangle.
Second check.
What do we got there?
Well,
Taj Mahal, or?
the detail on the glass. That's
All right, we put a little design on there, okay. Not bad. Whoa, Nick, that's pretty good, not gonna lie.
It's very
That's the best control tower I've seen here. Is that like a spaceship looking up, or feel like the doors are gonna open?
No,
Oh.
those are windows.
Okay.
I feel like mine's pretty solid. I mean,
This is the tower. Look, it's a little bit.
What is that? It looked like a mushroom just sprouted out of the ground. That's all that looks like.
Here's the kitchen machine.
All right. So what did we end up using here? Not tangent. This is the first problem today. No tangent here. 11. What was your x? Opposite adjacent hypotenuse. That's the hypotenuse. And what about this side here?
Opposite.
That's opposite, but hopefully we didn't use 5200 in your ratio. We use sine. I won't ask anybody there. Sine of 7 degrees equals opposite over x hypotenuse. What'd you guys use for opposite though? How long is this side here? Because it's not 5200, right? What did you do? 5200 minus
200.
I know my diagram's not drawn to scale, but yeah, 5200 minus the control tower height. So we should have 5,000 in there. Not drawn to scale because it looks like the control towers.
But that's the diagonal distance from the control tower.
What's that?
How does that compare the diagonal distance? So wouldn't it be 200?
What is the diagonal distance? So what are you asking here, Spence?
Well, wouldn't we use? Right.
You all right?
Yeah, I thought it was, but the viewpoint was the right triangle. So.
Okay. Hey, take a look here. First time we had to do this today and maybe in a while here. When you cross multiply, when you do the extremes, you get sine of 7 times x equals 5,000. Everyone dividing both sides by sine of 7. Just get x by itself. And what's our rounding here? Round your answer to the nearest foot. So how far away is the plane from the control tower here? 13.
I don't know if this is right, but I got 41,000
Yep,
and 28.
got it. Yeah. Hey, we're dealing with 5,200 feet. So, yeah. Yep, you're good. That's how far it is away. Anything else? All right, no more diagrams. We're going to go back to our quadrilaterals here. That's it?
We don't have.
Oh, we don't have that one? Good, I eliminated that one, even better. Okay, so you guys are gone then. You're on your own. Yep. Some of these are elevation and depression problems. Some of them are just word problems that we did yesterday, similar to what we did yesterday.
Alright, I'm gonna use it to show off. Alright.